You guys come back crying to me. I'm joking. I'm joking. I won't do that to you guys. So all good for 2-1. Okay. So what time is it? 1:15. Yeah. Okay. So I'll give you guys a break. We will finish really, really quick today, so don't worry. We're almost done, believe it or not. So depending how much we get through in 2.3, I'll give you guys a break halfway through or pretty much finish it. Okay. So I know it's almost been an hour, but I think we get through a couple more minutes when it comes to it. Okay. So last section for today, or last section for the week, is 2.3 functions. Okay. So before we get into it, there's a very special definition you will see all through math when it comes to it. And the funny thing is, the higher the math you go, the more elaborate these two things get into it. But it basically means, basically comes down to what this is. So the domain and range. So the domain is a set of all x values. That's all that means. It's basically saying, what are all the x values that make this true? That's what domain is. The range is a set of all y values, or in other words, it's all the y values that are possible when it comes to it. So if I go back over here, the domain is all the x values that make this true. Meaning I can plug in any x value that makes it true. And the domain is all the y values going up and down when it comes to it. So when it comes to an xy plane, this is the x and the y, but I can also say this is the domain and this is also the range as well. So they go hand in hand. Okay, so if you guys go into like pre-cal and calculus, you figure out, you get some fancy definition when it comes to domain and range, but it basically just narrows down to this, believe it or not. It just, I don't know why once you go into higher math, it get more complicated definition-wise, but it just, I don't know why there's, I like those books like, for dummies, just pretty much break it down, makes it easier for everybody when it comes to it. Okay, so, and we'll talk about a little bit of domain and range in this class, but not too much when it comes to it. Okay. Okay. The first major concept we're going to talk about in this section is function notation. Okay. So function notation is essentially everything we've done so far, right? But because we're in college algebra, it's a little different. So previously we had, like, if we have a line, we have something like this. Okay, which is okay. But, just like everything else, like in English, once you go into English classes in college, right, you don't say, oh, I had fun. You say, oh, I enjoyed myself, right? Because you're like all fancy because you know more vocabulary. Same thing applies in math. Like once you go in higher and higher math, we say like, oh, this is kind of like, elementary. Let's get a little bit more college level when it comes to it. And that's all we're about to do. We're just going to change one little thing. Okay. And the only thing we're going to change is, instead of this y, we're going to call it f parentheses x, or its official name f of x. Right. This is how it's called, f of x. Okay. Now, the reason why we call it like this is essentially what's happening is our domain is all the numbers we want it to be, like 5, 8, 7. And the only way, and this is our range, so the numbers like 8, 10, let's say -5. Okay. We want to figure out what's the bridge that connects the domain to the range. Okay. And we call it a function. And since it starts with f, we say f for function. Okay. Now, that is true and false. Usually you always see f of x. I'm pretty sure, if you guys see, so always see f of x, f. But you could have like h's, and, it really doesn't matter what the letter represents, but it's always in this notation. So, in us class, I'm not going to trick you. I'm always going to give it to you like this. But you could have like this, you can have that. They all mean the exact same thing. We just call it a G that connects here to here. We call the H connects here and here. But usually it's going to be an F, when it comes to it, make it easy for you guys. Okay. So the only thing that changes is this. Instead of y, we're going to say f of x equals that. So a function notation literally means this now. And now you're just talking about a function. Just change it. That's it. Okay. Simple as that. Okay. Now, because we changed it from here to here, we have a little type of different scenario we can do from. Okay. So let's say look at this example here. This example says y equals 3x minus 6. We want to find y when x is 6, right? So basically, I want to plug in x to be 6 and see figure out what we get out, right? So basically, what we just did in the last section, right? Just graphing. You plug in 1, and see what I get out for y. So we just plug it in, right? And we end up being y. Well, that wasn't too bad, right? Just plug and chug, and we're done when it comes to it. But unfortunately, now that we're dealing with this f of x stuff, I can actually break this down even further. Meaning I don't have to give it to you in writing, I can give it to you in mathematical terms. Okay. So if I just redo it now, so now it says f of x equals 3x minus 6. Instead of saying find y when x equals 6, I could just say find f of 6. And these two things mean the exact same thing. What this is saying is find f of x, find the y, when x equals 6. So this right here is that. All this is the abbreviation instead of me writing it all out. Math people are very lazy. The less words, the better, believe it or not. We even abbreviate words when you go in higher ones, believe it or not. So, the less words, the better. We're not very good English majors, so that's probably why. Okay? But again, the main concept is whatever's inside the parentheses, that's the x value, and you always want to find what the y value is. You just plug it in and see what you get out. So notice you do the exact same process there. Again, it's just abbreviation to instead of me saying all of that. So again, before we go into examples, any questions of what we just talked about? Everybody comfortable? Okay. All right, so let's try some examples out. Okay. So let's suppose we have this and this. So like I said, right, it's the same thing. It's just different letter, but they mean the exact same thing. So let's try some of these out. So let's first find f of 1. Okay. Now, we only get one answer. I'm only going to plug in 1 for the f. For example, if I said find g of 1, that means I would plug it into the g itself. Okay, so you got to identify f to f, g to g when it comes to this case. So therefore, I'm asking you, what does this end up being when I plug in 1 in for x? So we just plug it in and see what we get. That's it. So f of 1 is equal to positive 1. Questions there at all? Easy peasy? Okay, let's keep going. Let's now find g of 3. This one's going to be a little more difficult. So now that we want g of 3, therefore I'm not looking here, I'm looking there because I want g, right? G and g. So now this is saying, what is this end up being when I plug in 3 in for x? Now this we got to be careful of, right? Because I have 2 to put it, I have to plug it in here and also have to plug it in there. I can't just be one or the other, or here, or not, I have to put it both places. So this time g of 3 is going to be -3, or sorry, -8. And in parentheses 3 squared, right? So remember, I just insert 3 for the x value, minus 3. So again, before we go any further, everybody comfortable what we just did? assuming that's a yes for everybody. Everybody all good? Yep. So if we keep going, now we just simplify. So 3 squared is 9. Okay, so remember your order operations. Exponent first. This means multiplying. So negative 8 times 9. What is that? Is that negative 72? I think that's negative 72. If I'm wrong, you can just tell me, right? If no one says anything, I'm assuming I'm right. You guys can tell me. Pretty sure that's right. And then lastly, subtracting that gives you negative 75. So G of 3 is equal to negative 75. Questions on B? All good so far? Comfortable? Really enjoying this? Much better than chapter 1? Probably much better than chapter 1, right, when it comes to it. All right, so let's just do a couple more just for, practice sake. Okay. So let's try C. Let's find f of 2. And then D, go ahead and find, this is going to be a tricky one, G of negative 2. Okay. So here's your second extra credit opportunity. Go ahead and find both of them. Go for it. And just put it in the chat when it comes. So you just separate it with a comma. So like this one, comma, that one, for you to get both answers. Go for it. Go ahead and find both, April. Give you guys another minute if you haven't typed it in. Okay, everybody get them in. Remember, you can always at least try. Right? Okay. Everybody try one out. Okay. All right. So let's try this one out, see what we get. All right, so we're going to plug in 2 into here. So f of 2 is going to be negative 3 times 2 plus 4. So that's going to be negative 6 plus 4. So f of 2 is going to be negative 2. All right, so it looks like a lot of people got that one. Good. Nice job. So the next one is what looks like a couple of people. All right, so let's see. So we're going to plug in negative 2 into here. Okay. So now this is going to be positive 4. And I notice here, negative makes a positive 2. So that might have caught a couple of people. So you got to be careful of your negatives. So if we keep going, negative 8 times 4 is negative 32. And now subtracting those, negative 13 plus 2 gives you negative 30.